Okay, testing, testing. Looks like we got sound. Okay. Hi, Kira. How's it going?
Good. How are you?
Just fine.
Good. Okay. I'm not too far in the homework,
Sure, that's fine.
but I need some, and I think part of it is just because my brain has not functioned well today.
Okay.
I just need some math help, like
All right.
calculating math help
Yeah.
so
Sure, no
far.
problem. Yeah, the calculus is often the worst part of this for sure.
Oh, no, it's even just, I think this is even simple math, and the minute you tell me, I'm gonna feel kind of dumb.
Okay, I can do that.
So on number 16,
Okay.
I have taken the density function for y and I've solved it for x.
Okay.
I've done my derivative. And I know that I have to take my derivative times my f of x function in order to try and solve for k.
Mm-hmm.
But that's where my brain quit working on me, and I have
So
no
it's
idea
just
what to do.
not coming up with K there then.
Yeah, I just, like I said, it's something where I think I just need started and then.
Sure. Yeah. And I mean, it might help too. This is a 16, right? You said?
Yes.
Okay. So I guess, do you want to kind of check maybe some of the pieces that you have so far?
Yeah,
And then we
sure.
can just kind of go from there. That'll be easiest. So let me just add a page here. I'll pop that down here. Okay. Okay. So yeah. So I guess kind of where you at?
Okay, so when I solved the probability density function of y,
Mm-hmm.
when I solved that out for x, I got y over 2 minus 2y.
Okay. Let's see. So y over 2. Sorry,
Oh, I didn't factor out my 2, but yeah.
minus 2y. Okay, sure.
Yeah.
So yeah, we factor it as 1 minus y like that right there. Okay.
Yeah.
All right. So let's see. Trying to look at my notes to make sure that matches. Right. I think that seems about right. Sorry, just it's not as clean as I thought it was now that I'm looking at things. Um, hmm. I thought that I had a squared somewhere in here. Let me hold on just
Now
a
I get a
second.
squared when I do the derivative.
Oh, that's probably what I'm looking at, that part of my notes then. So okay, so yeah, so when you do the derivative, then you have so like do you have like the dx dy yet?
Yes. And
Okay,
so then when I took my derivative, I end up 1 over 2 times the quantity 1 minus y squared.
okay, that's good. So that's matching up. Okay, to there. So now we need to build up our g of y, right?
Right.
Okay, and so that's going to be dx dy times f of x.
Right.
Okay, all right, and so when we assemble that, now let's well, let's see. I guess maybe we can go ahead and jump into that. So when you tried to build them together, so you probably brought down this guy here.
Mm-hmm.
Okay, and then for f of x, we want that in terms of y, I suppose. So I guess that what I try to do, it seems like this is going to be the way to do it, would be right that we could take that expression you have for x, I believe, and toss it in up here.
Oh, okay.
Okay, because it's because we're trying to transform that guy, and in fact, if we look at if we kind of look at where that formula comes from, it'll probably be more clear. Let's see. Oh, yeah. Well, let's see. Maybe not that theorem. We can go to the simpler version of it. Let's see. Oh, yeah, for the single variables. So let's see. Okay. Yeah. Here we go. Here we go. Okay. So when if you look at this guy down right here at the end, right, then notice that's f evaluated at w of y, right? And so that function of y that we came up with, which we called x, but you could call w. I mean, they kind of do it a little bit differently earlier on, but we should be able to toss that guy in, I believe, and work from there. So that
Okay.
way, because the goal here, of course, right, is that it's all a function of y.
Okay, so that's probably the piece that I was missing because I was trying to figure out what I was supposed to do because I have k, x, and y, and
Yeah. So you can't solve for them all in the same one to get it to equal a PDF, right? So
okay.
and then hopefully we can identify it. So yeah, so I mean it's a little bit of algebra, but I'll toss it in and kind of work on it a second here and see if I can kind of match what you're getting.
Okay, and I'll keep working mine
Yeah,
too.
yeah, go ahead. So, yeah. I think that should do it. Oh, hi, Teresa. Kara and I were just working on 16 here. So she had just gotten a start, and then we were both just working on algebra to see if it matched up.
Sounds good.
Yeah. So if you have any questions, feel free to yell. Or just, like I say, trying to kind of grind this guy out a little bit. Okay. I think I managed to clean it up a little bit there. And actually, too, let me while we're looking at that, I'm going to post another PDF that I scanned in for you guys. So give me just a second.
Okay.
Ah,
Why is it in here?
okay. Okay. Good. So I've got these will pop up in resources and materials here in a second, but these are a couple of documents that tables reference charts that I had. from when I took this class when I was in grad school up in Montana, and it's a really they have like everything we need for all these distributions on them.
Oh,
So
cool.
I'll put it in just under the week 5 handouts. So let me toss these in. So yeah, no, this thing got me through my PhD comps and everything. It's like it honestly is kind of a precious document to me. So I was really glad to get to share it with people. I spent a lot of hours with it. Let's see. It's amazing, really. It's in as good a shape as it is. I think it's the original copy too. I should really just email my professor someday and get like a clean version from them. Okay, so let's see. Okay. Yeah, there you go. It should show up under the week 6 units on there now. So that's just a handy one that has all the different distributions and their formulas, their mean, their variance, like all that stuff is just laid out on there. Makes it a little bit easier when you're trying to identify these distributions.
Nice.
Teresa, I don't know. Did you have any other questions you wanted to look at?
Actually, mine is that I'm having trouble with the integration on 29. I'm trying to figure out how to show you my picture.
Oh, sure, yeah. Let's see. Yeah, I believe if you're on just a regular browser, you should have a screen sharing option.
I was trying to turn it around here.
Oh, okay.
But I'm not.
Oh, that's true. If you have it in a document, then I can actually present.
Okay, I don't know.
Yours. I can actually see that. Okay.
Can you see that?
I can. Give me just a sec. Oh, yeah. Okay, I see it. So.
Okay, I got there, and I don't know if I'm on the right track.
Okay, let me write down what you have there, and then that way I can mark up on it. I don't think I can screenshot it with what I got right now, so I'll just go ahead and write it down. Sorry if you can.
You're fine.
Just hold just a minute. Okay. All right. So I'm seeing it looks like you're down to f of z equals 1 over 2 pi e to the negative 1/2 z squared times 2 the interval 0 to infinity e to the xz times e to the negative x squared dx. So let me present my screen now, and then that way I can see if is that what you got?
Yes, that's what I've got.
Okay, all right then. Yeah, so
I tried doing some u substitution with the e to the xz.
All right. Yeah. Yeah, that's it's going to be a little tricky. Let's see. So just to check. Well, I guess what I'm sort of hoping, and I'm pretty sure that we can do it this way, is to see if we can tackle this, but see if we can avoid having to do an integral, because I think that you're right that that trying to do a U sub on this is going to be.
Well, I did a U sub. I tried to break it up and I tried to look at just the e to the xz with the U substitution. And then I found somewhere in one of my old calc books something about using this and getting it into like a power series.
Yeah, that could very well be, like, you would need to find the power series for this and maybe work from there. I mean, just spitballing, looking at it too, is it possible that yeah, there's not going to be anything really we can do with those exponents that's going to be helpful.
Somebody posted something
Yeah.
about gamma to the 1/2.
Right. So that's what I was gonna maybe suggest, is that we could look at the gamma distribution to see. But this is just to check. This is 29, right?
Yes. Yes.
Yeah. Okay. Okay. So let me go grab the problem, and then I can kind of start as we work through it here. So because what I would hope, because while it might be possible to do it like that, it sometimes is nice if we can shortcut this by using other properties. So let's see. So for example, let's see. So we know that that x and y are standard normal, and so because of that, what do we know about their distributions then? Could we go ahead and say what they are?
Yeah, I had that f of x was equal to 1 over the square root of 2 pi times e to the negative 1/2 x squared.
Okay. Okay. And then of course the same thing for y.
Correct. Correct.
Also standard normal. Okay. All right. And okay, so now we're going to now we're adding them together, and actually this might be a place where that we might be able to save ourselves a little bit of work. Let's see. Trying to remember what material we have access to here, because have we done the moment generating function option yet? No, that comes in the next section. So we need to try and do this with the techniques that we have here.
I did a joint distribution.
Right, that's what I was going to say, because setting it up as the joint is probably the easiest way. And for a joint distribution, did you get something that looks like, let's see, I think probably looks like it would be f of xy is going to be 1/2 pi e to the negative 1/2. And then did you just get x squared plus y squared?
Yes, and then that's when I used their hint and completed the square.
Okay, good deal, good deal. So that's 1 over 2 pi e to the negative 1/2. Okay, so x squared minus z minus x quantity squared. Okay, all right. And then, so we can plot that in. And actually, well, and I guess it kind of depends on how we did it. Or sorry, actually, I have a little issue there. I just think I just fixed him. And so yeah, there's a couple ways that we could tackle it, but oh wait, let's see. Yeah,
I left mine with x's and y's, so mine ended up looking y the quantity squared minus 2xy.
Okay. And so then you had to add and subtract.
That's what I did.
Yeah, 2xy. Oh, okay, sure, right. And that, I think that would probably work, but yeah, this is the. I think that this other method here might be what they were shooting for. Let's see. Let me just a second.
Okay.
What was I thinking there? So because I mean I got to it just by more or less right, just a straight substitution. So right, if I kind of go back to here, I think this will let us avoid the integral. Is what I'm really hoping to do. to see if we can actually just get everything in terms of as much z as possible, and then see if we can hopefully make it work out. Okay, may not work, but it's worth trying, because as you see, those intervals get pretty horrific pretty quickly. So let's see. Okay, so I just plopped in for y there, because z minus x is of course y.
Right.
Draw out. Okay, so let's see what's going to happen here. I'm hesitant to FOIL that out. It seems like this should simplify a bit on me.
Well, if you FOIL it out, I think you get back where I was, I think.
Yeah, that's very, yeah, sure. That makes sense, right? That it probably should come back to pretty much what you had. Let's see. So I'm trying to decipher what one of my next lines was here. So let's see if I can make sense of how I got to this next one. You know how it is. Sometimes you work these out, it's really flowing, and then later it's just like, what was I doing?
I agree.
Okay, so let me try something. Here's the next step that I was looking at. Let's see, how did I get to there? I'm wondering if I had some scratch work that I tossed out or something. So that would be subtracting it. Okay, hold on.
So what did you just do?
Yeah, that's what I was trying to figure out too. So give me just a second. That had a piece there. How did I pull that off? Let's see. So I was trying to bring that through. Okay, to break them up. No, that's not right. That's okay, let's play with this just a little bit. Okay, so certainly. So if I wanted, I guess I'm just going to play around with the exponent here. Let's just see what we can do up there. If we had, I could pull out a negative. Well, no, I don't want to do that. That's going to be a pain. Well, okay. I mean, let's just make sure that my algebra is even correct. Maybe something went wrong here. So if I try to reverse engineer this, then I could. Okay, I could. Let's just add these two exponents and then see if that even works out. Now I'm starting to get a little bit suspicious of it. That's divided by half, so that's going to get 2. Yes. 2. Huh. Yeah, no, that. Not sure what I was thinking there. Yeah, because. Well, I don't know. Maybe let's run with yours. Maybe we can carry it down. Maybe I can arrive back at this. It might be best to go ahead and multiply it out. So what you had, if I did go ahead and simplify this a little bit up here, so I'd end up with x squared plus, let's see, or minus, looks like. Well, I guess I'll do the first part first. So plus z squared, and then minus 2xz, and then plus an x squared, right? Yeah. So, okay. So that's going to get, oh, yeah. Oh, okay. I think I'm starting to see it now. And, it's like I always tell my college students, I'm like, don't get rid of your scratch work. And then what do? I got to go and get rid of it. So it's
right. That's what I tell my kids too.
Yeah, I know. It's well, it's what I've found is if it's on paper, I don't get rid of it. If it's digital, though, sometimes I'm just like, oh, I'll just erase all that file. It wasn't necessary. Okay, so if we get this out, we're going to get to 2x squared minus 2x z plus z squared.
Right.
Okay. Of course, easiest to complete the square when we go ahead and try and factor a 2 out of everything, right? So I'm just
You're
going
going
to
to factor it. You're going to complete it. Did we complete it twice then?
completing it. Well, we haven't really done a
Oh
completing.
no. Okay. Okay. I'm with you. I'm with you.
Yeah. Yeah.
Okay.
All I did was
Okay.
yeah. There you go.
I'm with you.
So I could go ahead and pull the 2 all the way out, but I think I'll keep them in, and then we can just work this little mini problem up here.
I was thinking I did complete the square, but I don't think I did.
Okay. Yeah. That could be. You just kind of we just distributed, right? So let's see. So just a little completing the square there. So let's see. You know, just to make this a little easier to see, I'm going to write zx so that way I can catch the pieces. Okay, so I'll just do a little mini problem here on the side. Let's just complete the square on that expression. So we've got x squared minus zx. And what would I need to add to be able to combine it all together to get a perfect square? Well,
Z squared over 4.
okay, so you got z squared over 4, right? So that would just to check my algebra, right? That would go to z over 2, so negative, right? There we go. Okay, good deal. So I'll pay for it with a negative z squared over 4. Oh,
well, z squared over 2.
Oh, sorry. Yeah, plus a z squared over 2. That's already out there. Okay. And so that's going to...
We don't have to worry about the 2 out front yet?
Oh, we will in just a minute. I was just,
okay.
Yeah, just kind of simplifying down the exponent part. I was kind of hoping I might see some simplification before I had to tackle too much. We'll see, though. Okay, there we go. All right, so yeah, so now let me toss him back in and see what I can arrive at. So the 2 is going to come through. Yeah, I'll just go ahead and I suppose. Oh no, here we go. Maybe it might be easier to go ahead and. No, I don't know. I don't think it makes much difference. I was going to say combine the 2.5 and then factor out a 1/2 of the whole thing, but I think it's probably easier just to tackle it as we have it. So e to the negative 1/2. So I'll bring the 2 back through, I suppose, through that whole expression, which just to highlight, right? Like those parentheses should match up with those parentheses, right? So that's what should plop into there. Yeah, I think that this will work. Okay. Okay. All right. Now, okay. Yeah, I think I'm starting to see a little bit now what I was thinking. I'm seeing where that came from. Looks like I tried to factor like a 1/2 out of everything. I wonder if it's just something to do with the weird way that I completed it the first time. Yeah, I'm kind of feeling like we might just be able to run with that because you know, part of our goal here would be that maybe we can get this in some sort of a form of a normal if we can
right
keep massaging it, right? And in fact, I mean, intuitively, we can actually even go ahead and predict what it's going to look like. So sometimes I'll sort of cheat and peek ahead so that I know where I'm going to head, because if you think about x and y both being standard normals, if we're just going to add them together, well, intuitively, if they both have a mean of 0, then the mean of z should be 0, right? Because the means are going to stay the same. They go to 0, and you never lose variance. We only ever gain variance, and so intuitively you might think that they each have a variance of 1, and that we should arrive at a variance of 2 in that case, right? And so we can actually predict, that we're going to end up at something like e to the negative 1/2 times, well, let's see, it would be, okay, so let's see, we'll have to build that in. So it's going to be z, right? And then over, so that's going to be sigma. So sigma squared needs to equal 2. So sigma is going to be √2 in the denominator, and then that would be squared. So that's where we know that we need to head if we can get there. And I'm pretty sure that if you, as I recall, it's really just a matter of monkeying with this algebra long enough to get it to fall out. Like I'm fairly certain that if we continue to play with it, that we can get those expressions to match up
without actually integrating.
Exactly. I'm pretty sure we can do this without integrating. Yeah, I think that. Now that said, sometimes the integrating might be easier than the algebra. So if you see a way to do it the other way, you might plow through that way. But I admit, a lot of times when I'm working with the normal distribution, because those integrals can be so difficult, that I avoid them at all cost. Even if it is at the price of an hour or more of algebra, Okay, let me. Yeah, here, let's see, maybe. So if I bust, let me get rid of this. I think it's tainting my my perception of the country. So, okay. I'm trying to keep that 1/2 because I really want to turn it into that final form. So I keep trying to keep him out there. I hate to get rid of it.
I was going to play around with it here too.
Yeah. See, maybe one of us will get lucky. Okay. Also, first of all, I know we're going to have to bust it up into 2 powers. I think that would go around this side. Okay.
I think did we complete that square, right? Because
that's just what I was looking at. Like,
I think we factored you factored a 2 out of that z the z squared term, and I think maybe we should have just factored it out of the term, I think.
Yeah. Oh, good catch. Oh, how annoying. Well, so
Because that gives me a z squared over 2 there.
yeah, so okay, hold on just a second. I pulled a
I think we pulled an extra 2 out.
yeah, I think you're right. Okay, so let me track my 2. So he came out of there, he came out of there. Now I created a half there to account for it. So if I distribute back through, that matches, doesn't it? I think. No? Okay. So then if we look at completing our square, gosh, I wonder, maybe we should just try to, well, okay, I know this should work. It's always so frustrating when it's not doing what you want it. Okay. Oh my gosh, of course. So yeah, it's always and I can never tell sometimes if I'm just being dense or it's just late at night. I mean, so just to note, right? Negative 1/2 z squared plus z squared is just plus 1/2 z squared.
Okay, yeah.
Duh, I'm just being totally dense. Like I don't know why that was so hard to see. You know, like it's to me for some reason I just couldn't
All right.
couldn't combine those two.
Okay, I'm with you.
They're right. I mean, it's literally combining like variables, but I don't know. You know, it's just hard to see sometimes. So there we go. So 1/2. All right. So now let me. I think that what I want to do now. First of all, let's bust this guy up. So that one I'll go.
Okay, I'm with you. I got that now.
That makes sense. Yes. Isn't that frustrating? It's just so. It was right there in front of me the whole time. So, and then I'll go ahead and bring that piece over here. Okay, so now that one there, let's. I think I can sort of start to get it into the same form. Okay, if I want to imagine factoring out. Really, I'm just trying to combine that all up into one fraction. So, yeah, squared. Oh, maybe that would. Oh, okay. I think this might do it. So if we kind of view this. Okay. Let's look at that. Oh no, I've got an extra square. Okay. So what I kind of did is sent the 2 down to the denominator as a 1/2, right?
Okay.
And then what that lets us do, lets us write it as 1 over root 2 down there, okay? And then I can see the whole piece squared. Let's see. Okay. All right.
Okay.
And then, yeah, still not really. still not really liking how that's going to turn out. I was thinking maybe that I could because I could on the second piece, I can imagine in it taking it and writing it in terms of z over root 2 squared, right? So as you can see, I was trying to introduce that little piece down at the end of the root 2. Okay, so now I guess that what do we need to have happen? We need to introduce this constant out front. We need to get him in there somehow. So maybe if we took this guy, we busted him up, that's 1 over root 2 pi times 1 over root 2 pi. So I could give one of those to each of my expressions if I wanted to. I'm not sure if that would help any. Yeah, I'm still kind of stuck with what to do on this front guy here.
I was gonna say, because we've pretty much got it on the.
Yeah, right. Like that's getting it on that side. So maybe I need to squint and look at what we're dealing with. Okay, so so there we go. I think I managed to copy all that correctly. All right, so this, right, that's a normal distribution there for sure. And what could we say about it? It has a, I'm just trying to see if we can maybe tease something out of that form that might be able to help us.
Okay, let's see.
We know they're independent. We can certainly, I can see that's a normal with a mean of z over 2, looks like, sort of, right? And then a standard deviation of 1 over root 2. Oh, yeah, gosh, I gotta say, I'm not. Yeah, I feel.
Enumerate that.
Yeah.
Did it turn into 1 at all?
Yeah, that's what I was sort of hoping, that maybe if we could make any sort of argument as to that, and I don't know.
Because if it's a normal distribution.
Oh wait, okay. Oh, hold on just a moment. So do we know anything about how x and z are related? Right. Well, we know that
Right.
Yeah, no, that's. I was hoping maybe that we could draw a relation, because right, what would be ideal would be if, say, the x minus z over 2 were 0, right? Because then that would take out a whole chunk for us. Yeah, but could we be so lucky? Let's see. Gosh,
I'm missing something.
Yeah, me too. And I swear that it works. It seems like I worked it out like this last time I did it, and but unfortunately, it's one of those, you know, where I didn't really fill in the gap at the time. It made perfect sense, and
Right.
so it's tricky to come back and see how. Yeah, I may have to think on that one. I may have to do a follow-up post
Okay. I'll
to
play
fill in
around.
the
I'll
gap.
play around with that as well.
Yeah, yeah. See what you can come up with and look. But I feel like this has some really good legs because you know, we're getting a piece that we need so easily.
Right.
Um, hmm. Yeah, yeah. I'll think on that one some more. I feel like that there's something there that we'll be able to pull out. We'll be able to do something, I believe, with that chunk right there. Yeah, I'll think on that some more. Yeah. Were there any others that you were stuck on at a place? I can try and get you unstuck a little bit, but
The only other place that I was hesitant on was the second part of 20.
mm-hmm.
That's the first part, and I think I was having a little trouble getting started on the part B.
Oh, sure, okay, yeah. And so that one, I believe, would follow a somewhat standard procedure for these change of variables. It always gets a little messy when you're dealing with piecewise functions, but oh no, wait, the first part is where you have the absolute value, isn't it?
Right.
Okay, yeah. So here we just have this guy.
Yeah.
Okay. And so, okay. All right. And how did you try to start him out?
I actually wasn't quite sure where to start.
Okay, no problem. Yeah. The the trickiest part on these. So first of all, we know the distribution for x, right?
Right.
Now we're trying to find x squared, and notice that they tell us that it's actually y squared. So that's going to be the clue to make our lives hopefully a little easier. So were you able to arrive at a distribution for y? So like a little g of y?
Hold on, I have it somewhere.
Mm-hmm.
I have 3y squared.
Good. So it's 3y squared when y goes from 0 to 1.
0 to 1. Uh-huh.
Mm-hmm. Yep, and 0 elsewhere. Okay.
Right. I do have that.
Okay, no problem. And so knowing that, then really what it's saying is, you know, don't focus on x squared, focus on y squared. All right.
Okay.
So knowing that, then we can, and there's a couple ways that we could tackle this, but I would probably say let's well, maybe I'll just use the first method they tackle, where we're going to take the derivative with respect to z. Okay.
Okay.
So that's going to leave us with 1 on this side and a 2y. So it's kind of like implicit differentiation here, right? So the 2 comes down, and then we're left with y, and then we get a dy dz.
Mm-hmm.
Okay. All right. And we could solve for dy dz. All right. And in fact, we could even go ahead and, imagine substituting in for y here, right? So y as a function of z is going to be just root z. It often feels like you're just sort of playing, little substitution algebra games to get these to get all the pieces that we need.
Right.
Now, the reason I'm shooting for that is of course that I need to, if I sort of back up, the relevant theorem is going to be, let's see, find them for you. Well, I probably could have just written it down faster, but it might be easier if I go ahead and show you which one I'm using. So most, I'm not sure. It's actually related to this one right here, but it's a slightly different form of it. So there's a simpler version, I think, up here in the previous section.
Yeah, I think, trying to remember.
Yeah, it's all really the same
Yeah.
technique, but I was hoping to show you the one up here for ease of reference.
7.2 maybe?
Let's see. So 7.2, you say?
Theorem 7.2 maybe?
Okay. Oh, in the section, you mean? Or is it like an equation number?
No, I guess theorem 7.1 on 211. Is that what we're
Oh, gotcha. Thank you. That's probably it. Okay. That seems like about the right section. 211. Oh, I guess my book has different pages. Well, that's great. Yeah, theorem 7.1. Yeah, that one. That's the. Well, okay. Yeah, I'll just use this one then because it is the theorem that we're looking for. That in this case that we're going to have g of z, right? Because or h of z, we may as well say. Okay, and that's going to be g of now w of y, right? So w of y, that's really in our case going to equal z. That's going to be what does z equal as a function of y? Okay, and that's going to plop into the PDF for y. So we're gonna plug that into there, and then we're gonna multiply it by this other chunk here, which that's the derivative of this function where z was a function of y.
Okay.
So that's what we just then did. So if we go down to our work now, just to kind of label some of those pieces so they'll look familiar. This right here, right? Z is w of y, and w of y is just y squared. Okay. All right. And if we can then take its derivative, so when we're searching for that guy, all right, that's okay. So we've got dy dz. So really, I think that all we should need to do is to plop this guy in. So h of z is going to be g of the this function solved for y, right? So that I can plop that in. So if we look at y equaling root z, then I'm going to have 3 root z squared is going to be g. Well, that got really messy. Sorry. Okay. G of y is going to be 3 root z squared. Okay. And then I do need to multiply by the dy dz part here. Okay. And then, so that should get us down to now plain old, everything's in terms of z, which is always our goal by the end of these, is to have all the y's ironed out and have it just solely in terms of z. Now,
Okay. Yeah.
Yeah, I think that works.
Yeah, I think that looks good.
And I think something like that should work out. So, I mean, you might go back through and make sure I didn't make any errors, I think.
Yeah, it looks about right.
Okay, yeah, I mean, I would check it and see. For some reason, I think we're okay, but I'm having sort of a hesitancy about that Z up there. I felt like, for some reason, I thought he was going to disappear on me. But,
Well, if I rationalize the denominator, it would disappear.
yeah, that's true. That's true. So that might be part of it. But yeah, maybe check back through the work. But the trickiest part getting started on these is usually just sort of getting that change of variables
Right.
started out, and then once you kind of start tracking pieces through, then it should start to fall together after a little bit. So.
Okay.
Good
Thank you.
deal. Yeah, hopefully that's enough to get you rolling.
Yeah, I think so. I'll just work on that 29, see what I can come up with.
Sure, no problem. Oh, thanks, Bill. I just noticed. Yeah, he was there with the theorem that we needed. So, I wasn't looking in the chat. So.
Okay, well, I think that's good for me.
Oh yeah, no problem. Yeah, me too. Probably in a bit, unless there's any other just lingering questions that you guys had.
No,
I'll put up a video of this too, so you can watch it. So.
Oh, good. Thank you.
Mhm.
Have a good night.
Sure, you too. Good night.
All right, thank you.
Sure. Did you have any particular questions, Bill, or just kind of checking in? Oh, no, everybody's gone.